Hello, everyone. Welcome back. This is Leetcode 886, possible bipartition. Before I begin, I just want to thank those who left comments on my videos 9 months ago. It gives me the motivation to make some today. Thank you very much. And for anyone who's listening, please do make sure you can like and subscribe. It gives me motivation to make more of these videos for you guys. So basically, this is possible bipartition. It's an interesting Leetcode problem. The question reads, we want to split a group of n people labeled 1 to n into two groups of any size. Each person may dislike some other people and they should not go in a group together. So basically, those who hate each other shouldn't be in a group together. So given the integer n and the array dislikes, where dislikes I, right, A sub I, B sub I, in the case that person labeled A sub I does not like person labeled B sub I. So return true if it is possible to split everyone into two groups in this way. So this question is a question about bipartition. So basically, it's about us being able to make two distinct groups. And by me mentioning two distinct groups, I'm sure many people will be thinking, oh, okay, groups, the extension, the joint sets, union find. But that's not the solution I'm going to give. I'm going to even use a simpler solution. And I think if you have solved a different equal question, but basically the same concept, right? Which is I think it's graph bipartite, right? Like is this graph bipartite? Basically, that question is best solved with the graph coloring like solution, right? This is like a graph coloring problem, exactly. So I'll just take you guys through like how to solve that. Okay. So basically, we have the graph 1, 2, 1, 3, and 2, 4. And these are the pairs of people who dislike each other, right? So 1, node 1, he dislikes 2, and 1 also dislikes 3. And I guess 2 and 4, meaning 2 dislikes 4, right? So we have this graph. And if you do simple graph coloring, I'll make this one red, blue, red again, blue again. So we see we can like have multiple groups, right? We can split this guy, and then they'll be in one group, right? So it'll be 1 and 4 in a group. And then we have 2 and 3 in another group, right? So this is how we'd use graph coloring to, solve the problem. What about a different example? So what about this one, for example, right? We have 1 and 2, 1 and 3, 2 and 3. If we were to draw the graph, we'd have 1 connected to 2, right? And 1 again connected to 3. But now you can see that 2 is also connected to 3. So no matter how we calculate the graph, let's say we started with R, B, we'd be here at R. So you see, there's no way we can split this into like two equal groups, right? If I took this guy and this guy, right? This guy would be with our partner. And again, it's not a bipartite graph because it's cyclic also, you can see. So these are the challenges that we face, but with the graph coloring algorithm, right, we're able to solve this problem. So it shouldn't be too hard. We should do it with BFS, and I just want to jump into the code. So we are given this question, and again, the answers is like first group has 1 and 4, and second group has 2 and 3, and this one we couldn't, split them up. So we want to first create our graph, right? I'm going to make an adjacency list. And it's an array list of n plus 1. I'm using n plus 1 because I want to do I want to account for like the 0th position, and also I just don't want to be like decreasing stuff. And it starts from the first node starts from 1, right? Like it says it's labeled from 1 to n. That's why I have it like this. So I have the adjacency, and for each section, I'll just put in an array list, right? So right, so simple then. And now we want to build the graph, right? So we have the in the slides, and take the source node. Notice that the graph is bidirectional, so like I guess maybe the source node might not be the best term to use. But then we have adjacency of U, and so that add node V, right? And the adjacency of V again, I will add node U. So we are done building the graph. Now we need to process the nodes, and it will help us to process the nodes if we were able to keep like a record of the colors, right? So I want to create an array called colors, and in this array to be n plus 1 again, and I'll fill it with -1, right? Fill it with -1. So -1 will mark a node that has not been colored. I want our red to be 0 and our blue to be 1, right? So that's how we are going to do it. So now after like having the colors array, what I want to do then is now do a BFS, right? So we want to start from the first node, right? Q1, and then we go through colors. And yeah, so basically I want to check if it has been colored and make coloring from that on. So colors of K is -1. That means it has not been colored, right? And now here's what I want to do. Our BFS, do the processing. So what? So I want to make a queue of integers, and I'll call the queue, I guess. And then some new linked list. And then basically the node K will be our first node added to the queue, right? So, and then we'll pop the queue later on, which is just here, right, in a while loop. So while the queue is now empty, we want to pull for the first element and then process its neighbors, right? So we'll go to each neighbor and cover it basically, right? So I'm gonna say its current node is what queue.pull, and then we can get its neighbors from the adjacent series, right? So current node, sorry, I want to say that the neighbors is equal to the current node. Yeah, so the adjacency list position current node. Yeah. So we have the neighbors now. I want to go through each neighbor. Right? So for each neighbor in neighbors, what I want to do is first check if it's been colored or not, right? So if colors of neighbor is -1, then I know it hasn't been colored. So if it hasn't been colored, I want to make sure that if I'm on a red node, the next one, for example, will be what? Blue. And if I'm on a blue one, then the next one will be red, right? I want to split them into two different ones. And how I can do that is to say that, okay, then the color of neighbor, it should be 1 minus what? The color of the current node, right? Right. So 1 minus, so basically, as I was saying, we have like two colors that we're looking at, right? 0 and 1. I guess 0 will be red, 1 will be blue, right? So if the color of the neighbor was like, say, 1, right, then we'll have 0, and then to alternate, if it was like 0, then to be 1. Yeah. So basically, I set the color of the neighboring node, and then I add the neighbor to our queue for processing, right? So basically, that neighbor is being added to the queue, and then later on we'll process its neighbors also. So I will make sure that we go through the whole graph and make sure that every single thing is colored. But again, if it's already been colored, then I want to check if its color is the same as what's the color of the current node. Because if it is, then we have like then we are sure that we can like bipartition the graph, right? As I showed you guys in the example. So in that case, we return false, and basically that's that. If it goes through and every node is colored successfully, then what we want to do is then return true, right? Say that yes, it is possible to bipartition the graph. So I'm going to run it. Oh, if colors, okay. Is that, yeah, pass the first three test cases. Let's submit. Right, so beats 50%. I think it was like 19. I did it previously already. Like it was 90. I don't know. I guess that's that, right? Like 16. I don't know. It's a bit wonky, but like basically this is how we get through the question, right? What is the time complexity? Well, basically building the graph, it's like I'm going to touch each node in the graph, right? So again, it's n, O of n here, and basically the processing to is O of n, right? Like I'm on a node and I go to its neighbors, right? O of n. So in the worst case scenario, right, we go through each neighbor, and I guess the worst case is that like like and no, every node has like the same neighbor and stuff like that. But I think if it is that case, it will return false early. So I'll say overall it's like O of n, but worst case scenario O of n squared for like the BFS and the processing, right? So in general, I'll say O of n squared solution. I want to submit it one more time. Come on, it's like I got like 90. Come on, okay. That's that, guys. Peace. Yeah, do like and subscribe, please. Thank you. Bye.